but I made a mistake. I didn't say Java 9, and I didn't say Project Jigsaw, so I forgot all the buzzwords. Damn. So now I put a 9 in there, so you know what this is about. This is about the future, but we'll talk about that in a moment. My name is Nicolai, and I don't want to bore you. Let's get to it. Before we start about the technical stuff, I want to exchange some thoughts about where we and the JVM do not share the same opinion. And if you have been sitting here for a while, you might have seen the slide was up for the last 10 minutes. How do you think about software? Like, you're not supposed to tell me, just answer it for yourself. What is it made of? Is it bits and bytes, lines of code, I don't know, UML diagrams, Maven poems, something? So I can tell you how I see the projects I work on. For me, software is like a system of interacting parts. I think of them as things that have names, and they depend on each other, and they talk to each other and interact, and each of them has certain capabilities. So this creates a graph, much like in the background, where in my head there is this, maybe these are classes talking to each other, or jars, or in a microservice area, this graph would be the different services connecting to each other. And this is how I view software, mostly. So when we talk about the layer of artifacts of jars, then the JVM sees things slightly different. Jars are, when we say one part is one jar, then we said we have names and dependencies and capabilities, and for the JVM, all of these things do not even exist. The JVM does not really know or care that a jar has a name, has a file name, but it doesn't have a real name that it can use. When a jar depends on some other jar, like the code you wrote depends on Guava, the JVM doesn't know. It tries to load immutable list, and it doesn't find it. It just breaks at runtime. It just doesn't understand this concept of dependencies. And a jar doesn't have a coherent surface. What I mean by that is that you can decide when you write your code whether something is public or package private, but if it's public for everyone running in the same JVM. You cannot say, this is public for everyone, and this is just public in my jar. This concept doesn't exist. And the reason for that is that the JVM takes every code that is in the jars, rips it out, puts it to one big ball of mud, and that's it. So the whole jars disappear. On the file system, they are there. At runtime, they're just not there. And I totally like this image. So this was our great graph down there, which we modularized and thought like which part depends on which. And then comes the JVM, rolls into this ball of mud, and there you go. Well, boo-hoo. But it actually has negative consequences. Before build tools were a big thing, it was kind of painful to import projects which had a lot of dependencies, and all of them I had to find manually and put them in my lib folder and stuff like that. That mostly went away with build tools though. But then there's shadowing and version conflicts, and what I mean by that is that if you want to load a class, the JVM just runs through all your jars and looks for a class with that name and just picks the first. Maybe by some kind of accident you have the same class like 3 times in your jars. You can't tell which one is loaded. It's the first one, but which one is the first one depends on things that is not under your control necessarily. So it might be different on your IDE than it might be on the production server, which creates some great bugs. Version conflicts is a real problem. If you need Guava 19 for this dependency, and this other one needs Guava 16, and there are some incompatible changes between 16 and 19, then basically you're screwed. You can't do anything. Either you pick 19 or you pick 16. You cannot have running both at the same time, at least not without additional tools. This also makes it slow. Loading a class means checking all files, because the JVM has no idea where it might be. And it's unsecure, because within this ball of mud, there are no real checks. You can activate the security manager, and then it tries to make as many checks as possible, but if some developer at Sun or now Oracle, forgot to put a security manager check in some place, then the call just goes through, and this actually happened. One of the many security problems that Java had after Oracle bought Sun, before Java 8 came out, of the many fixes they had to do, a couple of them actually related back to exactly this thing, that the developer has to think about, wait, this is a module boundary which exists in my head but does not exist in the JVM, and I have to put this call, the security manager call here, and they forgot it, and then the call went through, and boom, security problem. And it creates, especially for lib developers, a maintenance nightmare. Imagine you're writing some library that you offer to the world, and you're really strict about, these are the classes that are public and you should use them. And then I have my own classes, and they're in a package called internal. Maybe it's called even internal.do not use this creepy package. But nobody cares. They have a use case, they need this class, they're going to use it, there's nothing you can do about it, and if you change it later, people start complaining. Because you have no way of telling JVM that this is mine, it's public within the jar, but please, please don't give it anybody else. No? Yes. So enter Project Jigsaw. What it actually does, it teaches the JVM about that graph that was in our head, so the JVM can understand it. Quick history. There's huge amounts of background story on this, which other people know much better than I do, and they could be talking about this for days. But this is like really the rundown. So it's old. Like 2005 was the first time that it was discussed that maybe we need a module system within the JDK. And then there was, the OSGI community said, like, we have this, like, why don't you use this? And then they didn't want to, and then they created Project Jigsaw. And the idea was, within the next year, for Java 7, we will have Jigsaw. It will be modularized JDK, and everything will be nice. Well, it didn't go that way. So first of all, Java 7 was delayed, and then even Java 7 Jigsaw didn't make it in 7, didn't make it in 8. But now the exploratory phase is over, the prototype is released, and it's pretty, let's say 98% sure that it's going to be in Java 9. So this is going to be the future. Project Jigsaw will come, and it will bring with it some changes. But that also means that what I talk about today is based on this prototype. So things can change, which is good, because we can still have some influence, and which is bad, because some of the details I might tell you later might not be true anymore in a year when you start using it. So this is just to get an impression and to give you the chance to judge what it does to your system, how you can react, and maybe even provide feedback back to Oracle to change how it works. Tip of the hat to people from Amsterdam. Okay, what are the goals of Project Jigsaw? The goals are more than these, but these are the important ones, especially the first two. Reliable configuration means the JVM understands that jars have dependencies, and then you cannot just start running as soon as you find a main method. No, but you actually have to check whether everything is there. And strong encapsulation is the second, which means that you will now have this surface. You can now say, this is on the surface for everybody to see, but this is mine, and then you can be pretty sure that nobody's going to touch it. And one of the things that actually led to the whole idea of a JDK that could be modularized was the idea of scalable systems, which is important when you're doing embedded devices or mobile, or even now with Docker, it gets more and more important, because the question really is, why would I need like the huge swing JavaFX AWT stuff in my REST service? Like, it doesn't make any sense that it's there, and it takes up huge amounts of space. So you can scale the JDK back to the parts that you need. Then that's basically the opposite of what I just said. Security is improved because you can't just jump across module boundaries. Performance gets better because now the JVM can actually guess when you load a class where it should be and look in there. They will also have the jar file format, will not be jar files anymore, but some internal unspecified format which they can use to optimize the loading process. So performance is supposed to get better. And with strong encapsulation comes the maintainability for the JDK developers, but also for library developers to finally be able to forbid people from touching all the good stuff that I'm not wanting them to. Okay, if you remember nothing from this talk, but one slide, make it this one. So this is how Java 9 will solve all the problems that I just talked about. or reach all the goals I just talked about. Actually, they will not solve all the problems. It will introduce modules, and a module has a name that the JVM actually understands. The module expresses what it depends on, and the module encapsulates its internals. And I already repeated these three parts, these 3 bullet points, and I will repeat them again because this is the important part. And everything else that we'll be talking about today somehow follows from this. Maybe not directly, maybe it's not immediately obvious what the connection to this would be, but most of it is connected to this. And there's a heap load of stuff that we could talk about. We're not gonna though. So I'm not going to present all the features that it has, obviously. And you might have questions like, how would I solve this, or how would I solve that? And likely there's a solution for that. So there are things that I can show you today that might solve your specific problem. Okay, I like to take questions not only at the end, but also during the talk, so that what we just covered, like right now, we'll take general questions in the end, but what we covered right now, do you think there's something that do you have a question about that I should tell you about more? Oh, yes? I take 3 questions, so we don't have to take too much time.
Okay, so if you understand you correctly, we will have modules which will have their own dependencies, right? And it can be a jar or some other format.
We will continue to deliver jars most likely, but the JMod format is something that Oracle is going to use.
Okay, so then my question. So what if 2 modules have dependency on one jar? So will it be duplicating, or how it will be resolved?
Well, if two modules have used the same module, then they just have, then this module is just there once. It's like today, like if 2 different libraries depend on Guava, just need one Guava jar. Different versions. Yes, that's one of those problems that was not going to be solved. I'm sorry to tell you that while it was planned to introduce a version concept, they decided before coming out with the prototype that it would be too complex and it's going to be dropped for now. It is very unclear whether that will ever be reintroduced, whether they will maybe in Java 10 they will have versions for modules. I have no idea. I guess not. But yeah, so this problem still remains, which especially feels bad because this is like one of the big problems of jar hell that was still there, and it's going to be there still. So that sucks. Okay, that counts as 2 questions, so one more. No. I will talk about OSGI later. A little bit at least, if we have time left. But it's similar because it's also a module system, but it's different in the way it does it, very. Okay, so let's see some basics. We start with modules, like the nodes in our graph. And again, they have names. They express their dependencies, and now let's get clearer. They say specifically which packages they export. So this export mechanism works on a package-by-package basis. There's not going to be a new keyword. You cannot say this is not public class, this is module class or something like that. So this is the way it works. The code, the classes look like now, but now you have somewhere, and I'll tell you soon where, you will have you will state which packages you export. So what's a module? A module is a jar, just like today, and in there is a module info class. And this module info class will be compiled from a module info Java. And the module info Java looks like this. It's very simple. You write module, and this is my module name. It requires this other module, and you can repeat this, of course, as often as you want to. And then you say, I'm exporting this package, and this other package, and this third package. And that's already it. For many cases, it's a couple of lines, easy for demonstration purposes. It's a couple of lines. And this will be called the module declaration or module descriptor, depending on what you're reading. Okay, so now we have these nodes. Now I want to put them together. Somehow the JVM has to connect them. And this concept is called readability. This is not a word that I came up with. It's the word that you will find in the documentation, so it's worth remembering it. And readability is the basis for reliable configuration. This goal of having the JVM know which part connects to which, this is how it works. So when we have a module A and we write module A requires B in the module info Java, then we say at compile time, or when writing the code, we say A requires B or A depends on B. And at runtime, the JVM comes and puts like a read connection between those two. And then it says A actually reads B. There are other ways how A might read B, but let's ignore them for now. So we required it statically, and then at runtime, JVM turns into A reads B or B is readable by A. Well, it's the same. And reliable configuration is now very simple. Java will only compile and launch when all the dependencies are fulfilled and they're actually there. You cannot have missing jars anymore. There are no cycles. If you have cyclic dependencies, it won't work, because if you have them, you didn't modularize well enough. And there's no ambiguity. That means there are no two modules that say they have the same name, or what else is there? Two versions of the same modules, for example. So as soon as the compiler or the JVM finds a situation which is not crystal clear, it will just throw an exception and be done with it, which is good, because it breaks fast. Now, the third part is accessibility. This is as readability. This is the term that you're going to see in the documentation. And this is the part that hides the internals and implements strong encapsulation. And it immediately builds on readability. Because what happens is runtime, if you have a module A and it wants to load a class from module B, then it will check, is the type public? Okay, the type is public. Is this package even exported? It must be exported. And then, can A even read B? And all of these three must be fulfilled for you to be actually able to deal with it, to handle that class. So similar like today, for example, let's say you trick the compiler and you're using some private class or some package visible class. You know, somehow you trick the compiler and it compiled, and then at runtime the JVM will find out. It will do similar checks and find out, hey, there is this class indeed, but it's package visible. You're another package, you're not going to read it, and it's going to fail with, I think, an illegal access error, which is the same what will happen now. So the type must be public, the package must be exported, and the module must read the module exporting the package. This means, and this is quite new, that public is not really public anymore. Public now means everybody. Public then means, well, depends on what you will find in the module info Java. And the interesting thing is that it doesn't even work with reflection. You cannot work around this with reflection. So you used to be able to just do class for name or get a method, and then call set accessible on everything that you find, and at some point it works, and you cannot do that anymore. Again, on purpose, to keep you from depending on internals. There are command line flags to get you out of some problems. Like if you have real problems and the module system is in your way, and we'll find plenty of opportunities how that can happen, you can via the command line say, I know this package is not exported, but please for now export this package as well. So for example, you can do that. But during the running application, you cannot. Okay, so this would give this great boost in maintainability that I talked about. No longer can the use of your code depend on some internals that you never wanted them to see, because now the JVM is going to guard those internals for you. And this is also the reason why there was community unrest. I think the talk by Christoph Engelbert is tomorrow about SunMISC unsafe. I can totally recommend watching it. And it's dealing with exactly this scenario, because SunMISC unsafe is a class where you can do all kinds of unsafe stuff, like directly allocate memory, and nobody's going to use that, right? Why would we use that? But it turns out that a lot of our dependencies use it. A lot of high performance libraries use that, and not because they just want to be bad boys, but because there's no API which does the same thing with the same performance. So they used it, and now, well, everybody knew that anything that starts with Sun, you shouldn't use it. But you know, it's Java. It's like, I don't know, like 16 years nobody cared. Nobody ever deprecated, really removed something that was deprecated or actually forbid this. Well, now Oracle points to those 16-year-old documents and says, haha, but we're gonna. At least that was the plan. And then they decided, okay, if there's no alternative, we're gonna keep it until Java 10. So now there's a module which is called JDK unsupported. So you know it's really unsupported. And you can use that for another Java iteration And then they will provide APIs which do the same thing with at least the same performance. And then everybody must move out. Okay, let's do a small example. And you can find this on GitHub. Apparently I did this a while ago. So it's an advent calendar which is not fitting the season, but bear with me. So it's very easy. What does an advent calendar do? It surprises you with stuff. So we have a surprise here. It's an interface. And because it's Java, we definitely need surprise factory. Otherwise, it's not EE enough. So we have calendar sheets, and each sheet knows which day it belongs to, which day of December, and the surprise it contains. And then, not surprisingly, the calendar has 24 sheets. And then we have some kind of implementations for the surprise factory. It produces chocolate or quotes, inspirational quotes. Okay, this is the structure, and then we have a main method which binds this together. It's very easy. I had to cut a lot of code short, so forgive the compile errors that you would get. So we create a new chocolate factory and a new quote factory, put it into a list, and then calendar has a static factory method where we put the list in, and then we get the calendar out. And it does nothing fancy, it prints itself to the console, or it returns a string that you can print to the console. So this is our application. And this was before Java 9. And now Java 9 comes out. What we're going to do? The first thing, we don't do anything. This is a valid option. So when you think about modularizing your own application, you don't have to. You can simply go, meh, I don't care. Jars will continue to work as today, unless you do stuff that you shouldn't. We'll see that later. You put the jars on the class path just as before, and everything just works. So this is the easiest way to do this. Also the most boring one. Then there's the other one, which is almost as boring. You take the application, you put it into one big jar, and you say, this is my one module. So you have a module called Advent, and then you require some stuff. I used list, I depend on object, so I have to require some module, right, that gives me these classes. Actually, I don't, because Java base contains object, and everybody needs object. So there's really no point in everybody saying, I require Java base. So you don't have to. So I get object and list and stuff in Java base for free. I require nothing else. I export no API. I'm done. My module. I can now put this on the module path. We'll see that soon. And that's it. Still very boring. But we can see here how readability and accessibility works in this very simple example. I said that Advent requires Java base. So at runtime, the JVM comes along and turns this requires edge into a reads edge. At runtime, Advent can read Java base. And that means, because Java base exports all these cool packages, Java lang and Java util, that these exports become accessible to my code. So this was the steps we did. We have these modules, then we get readability when we require each other, and then we get accessibility for the exported packages. Sorry. Okay, now let's do actual modularization. We start with multiple modules. And how can we split this up? We have surprise and surprise factory. Both are interfaces. That looks like an API, so we put that into one module. Then we have the whole calendar thingy, and we put it into another module. The factories, they could be their own modules actually, each of them, but let's put them into one module. And then we have the main class, which is in Advent. And then this is the dependencies. Advent needs all three of these, and these both connect to the API. And this is a module graph, by the way, which also, this was also a module graph. You will hear that as well. The module graph is the graph that the JVM builds from the information we provide. Okay, so let's look at some module descriptors. Let's start on the right with surprise. Surprise uses nothing else. It uses object, but we already had that. So we require nothing, but it exports the package that contains those two interfaces. And then calendar, it's called calendar, requires the package surprise and exports another package. And if you look closely, I'll click now, you see the different factories. Damn it. which is very minuscule. So it's basically the same because it's, it's the same kind of relationship. It requires surprise and exports some stuff. And the advent is a little bit different because it needs all three of these, but it doesn't export anything. This is the one with the main method. Nobody's going to call into it except the runtime to start it, so there's no point in exporting anything. Okay, this is the command line to do this, which nobody ever does, and in the future as well, nobody will ever do. Let's skip this, it's there for reference, but the important part is what you see here is the module path. There used to be the class path, and the class path is still there, but there's also the module path. And when you put something on, when you say, this is my module path, then the JVM and the compiler will go in there and look for your modules. When you compile something and it says I depend on surprise, then the compiler will go into the mods directory and look for a module that says I'm called surprise. And again, if it finds 2, for example, it just won't do anything. Okay, that was like the crash course in how to create modules. We're now going to talk about migration, which might be interesting, but are there questions about what we just saw? Two. No. Oh, so the question, by the way, was, in case it didn't capture it, so does require support wildcards? No, you have to list them manually.
So does it mean you cannot have now 2 different versions of a module for your program? While you could do it with jar files, you could somehow arrange that both were on the class path. It's now impossible to have 2 versions of the same module.
Yeah, you could do that on the class path. It would run, but you didn't know what exactly would happen. But yes, now it doesn't work anymore, right? Last one, yes?
Sorry.
So the question is, basically, what about these files? Where do they come from? Is there some support? And the idea is that would it have been introduced before Maven and Gradle, then this would be the way to go. You would write this instead of your POM. But the JDK team, of course, knows that that's not the world we're living in. The world we're living in, Maven has been there for 10 years and doing a good job on Gradle. So their idea is that these classes, you won't write these files usually. You will use your POM to just describe everything that you have, and then the Maven plugin, the compiler plugin, will take out everything that it needs and generate this file for you.
So we need to duplicate this export into Maven or Gradle.
Yeah, exactly. But still, so the requires you can generate automatically, but what you want to export, you have to specify. But you only specify it, you will likely only specify it in one place, most likely the POM, and it will take it from there. So you won't have to do this in different places.
In case nothing is exported explicitly, does it mean that everything is implicitly exported or nothing is?
Nothing.
Thanks.
Which is also the default case, by the way. So if you just get a module from somewhere and it doesn't export anything, then everything is closed. Okay, that was the 3 questions. We'll continue with more questions afterwards. So let's talk about migration. How do we get there? Because what I just showed was we do no module, we do 1 module, or we modularize the whole application at once, which is great if you have 6 classes. Maybe you have more in your projects, so you need something else. And then immediately the question arises, why is this even possible? Because many module systems, OSGI, are totally in or out. So you cannot just say, I don't want to use that. I use some parts use OSGI, but the rest not. So this is not only true for Java, it's generally the case with module systems. But the JDK is modularized. And because of backwards compatibility, you want your not modularized normal class path jar file code to just run. So out of the box, you need to have a way to have these 2 cooperate. So there has to be some kind of interaction. And then also a migration. So there are 2 things that enable this. There are unnamed modules, or the unnamed module. Let's say there's 1. That's almost true. There's 1 unnamed module, and there can be automatic modules. I'll tell you in a minute what these are. But they are the mechanism that enable this migration. And jars, and that's also interesting, like jars that are modular jars, because they have a module info class, but also normal jars can both be put either on the module path or on the class path, which does not immediately make sense. Why would I put a normal jar on the module path? What does it even mean? We'll see now. First, we have the unnamed module, and this is the reason why the class path just works. The definition of the unnamed module is very simple, actually. It contains all the jars on the class path. So at runtime, the JVM will actually have a module. Even if your jars are not modularized, there will be a module for them. This is called the unnamed module, and everything is in there. Everything that you put on the class path gets, as before, rolled into one big ball of mud and dumped into one module, the unnamed module. It has no name, as I said, surprise, but it can automatically read everything else, so that your code can still read, for example, Java XML API. Because you don't have a module descriptor, you cannot say I require it, so the JVM has to put in these read edges automatically. And it automatically exports all packages so that everybody can see all the code in there. So basically, the unnamed module is just like before. It's like totally horrific, chaotic as a class path. So let's say I slimmed this down a little bit. We have our entvet jar, our calendar jar, and we use Guava. And these are just jars. This is how I did the round orange bubbles. These are just jars. And I put them on the class path. Then JDK comes along, puts it all into one module called the unnamed module. And let's say our JDK only contains these three modules. Then it just adds read edges to everything. And this is how the module graph would look at runtime. Okay, but this offers a problem that you're probably not easy to see immediately, but what if I modularized my code, but let's say I use Guava and it was not modularized yet. So I want to put my stuff on the module path, but you know, theirs is just unmodularized in the unnamed module. And the idea is that you could just say, hey, no problem, I depend on unnamed, I require unnamed, so now I can read unnamed. But that would be strange, because then this chaos that we want to leave behind us, suddenly I still depend on it. So that makes nothing much better. It's just a purely architectural decision. There's no technical reason for that this is not possible. It's forbidden, you can't use it, because you should not depend on the chaos of the class path. So that means this red edge doesn't work. You cannot leave the Guava jar back on the class path and say my calendar depends on it. Doesn't work. So we need another way. And this is where automatic modules come in, and they bridge from the modules to the class path. I said that you can put both modules wherever jars and modules on either path. And what does it mean if you put a normal jar on the module path? It means that the JVM comes along and thinks, apparently you want this to be a module, but it isn't one. No problem, I'll make it one. So now it creates one automatic module per jar on the module path. It gives it a name that it derives from the file's name. Like, let's see on the next slide what it does. It's very simple. Just it takes what looks most likely like the module name and puts it there. And then, because like before, it can't express its dependencies, it automatically reads everything, including the unnamed module, which is a trick, and exports all packages because it doesn't specify anything. So I put Guava 19.0 jar on the module path, and then bam, JVM derives the name Guava, and finally I can say requires Guava. So this is how it looks now. I put the Guava jar on the module path, the JVM created a module for it, and now I can depend on it, and now I'm here in this nice modular situation. So now we have seen that both modules and jars can go anywhere, and this is like the overview. If you put a regular jar on the class path, it turns into the unnamed module, or it gets all into the same unnamed module, and the same is true for modular jars. And if you put them on the module path, the modular jars behave like normal, well-established named modules, what we did before, and regular jars turn into the automatic models we just talked about. And this is how they can interact. And this leaves the way open to two migration strategies, which might be interesting to you. You can go bottom up. If you have a library and it has very few no dependencies maybe, you can just start by turning your own jars into modules. You put everything in there you need, like the module info description, and the clients can still put it on the class path. So just because you turn it into a module does not mean that the clients have to use it as a module. They can put it on the class path and everything will work as before. And they can move it to the module path whenever they want to, whenever they're ready. So this means that you can do this on your side without interaction on your clients. On the other hand, if you're having an application and you have tons of dependencies below you, then you have to go take a different approach. You can also start by turning your own jars into modules. But then come the thing with the dependencies we just talked about. And here just go, my dependencies, which of them are modularized? If they are, just put in the requires clauses. Or Maven does it for me, maybe. Those that are unmodularized, and then you put them on the module path. Those that are unmodularized, I did the same thing as before we did with the Guava. I just require it, and then I also put it on the module path, and then it gets into an automatic module and I can depend on it. And if in turn Guava depends on a bunch of stuff, I can put that on either path and everything is fine. So this means that we can, from the top, put our stuff into the nice module path, and then pull our dependencies in one after another, because when a dependency gets modularized, in the ideal case, its name didn't even change because the JVM derived it correctly, and then just nothing happens. It just stays where it is and everything is fine. I may have to check its dependencies, but otherwise, I can just slowly move all the stuff to the module path and maybe forgo the class path entirely. Okay, questions about what we just talked?
So the question is, if I have a project that I'm working on, what steps should I take during this year to make it ready?
This year we'll talk about that in a moment, because now you only have to you have to wonder about compatibility and what might change, and we'll talk about that right now.
All right. And the second one that it's kind of short. So is Maven or Gradle ready for Java 9, in your opinion?
So both of them are working on support, and the important part is that when Java 8 came out, most tools were instantly ready, because most tools didn't have to change too much. The same is not true for Java 9, so we should not expect that the day Java 9 comes out, everything just works. It's entirely possible that there will be hiccups, that the tools will take a while to adjust. This is to be expected and should not be taken as a problem of Java 9 per se. It just means that we have to work a little bit harder to overcome all the forbidden stuff that we did in the past, because that's mostly the problem. Other questions? Okay, let's talk about compatibility. We have like 7 minutes left, so let's see. Oh, what, damn it. Wait, what was that? Okay, whatever that was. Now I can't see the time anymore. You'll warn me. So now let's talk about compatibility, because that's interesting. Oh, great. No. Okay, great. Things can go wrong, and existing code might break, and this is true regardless of whether you modularize your application or not. I said that you do everything as today. You just put all your stuff on the class path and it just works. That is only true if you do none of the stuff that we'll be talking about very soon. So there's JEP 261, and it contains a list of risks at the bottom. If you're interested in this, you should really check it out. It will be more than I can tell you right now. So the first and most obvious one is that internal APIs will appear. Internal APIs are everything that is in Sunstar, and most that is in ComSun, unless it's annotated. But as we said earlier, some things might survive. Check JEP 260 whether the stuff you're using or your dependencies are using is one of them. And there are actually some methods which are going to go away, like just like that. I don't know whether they even deprecated, but they had to be because otherwise they were in the way of modularizing the JDK because they introduced some circular dependencies, so they decided to X them. But apparently nobody uses them. So what do you look for? You download JDK9, and in there you'll find JDEPs. In bin, you'll find the tool JDEPs, which is pretty awesome. It can do all kind of dependency stuff, and you can use this flag that's called JDK internals, and put it on to look through your class files or jars, and then it will print out all the violations that you have. It will tell you this class of yours is using this API. Don't do that. And you should use the one from JDK9 because this changes every now and then. This is the most modern one. You can put this into a build. There are 3 plugins that do these, and this one is mine, and it's obviously the best because, you know. We wrote this at work because everybody has violations, and there's not everybody, but you may have violations that you cannot fix like right now. So a tool that breaks your build as soon as you have one violation doesn't help you. We wanted to have a very flexible way to define rules like this package uses blah, 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 from which we shouldn't, we know. Please print a warning for these ones. If new ones arise, then break the build. And this is how we did it. So I can only recommend this, or there's the officially Maven JDEPs plugin, which you can use similarly if you're willing to build excludes with regular expressions. So also important, look for reflection, because JDEPs cannot find this. When you use class for name with a string, JDEPs won't identify it. So look where you use class for name, and especially where you use this, because it might not work anymore. If you use set accessible true to access a default package visible class in another jar, then this won't work in Java 9. And the problem is, this is true for your dependencies as well. Because it's great if your code doesn't do anything bad, but if you depend vitally on some library and it breaks, well, your application breaks and your customers are just as unhappy. So check your dependencies. Also, you can do, as the dependencies are jars, so you can use the same approach, at least this part, not this part. So when you find something fishy, what do? You should definitely contact the developers. Maybe they already know about it. Likely they already know about it. They should be fixing this. If they're not, because it's an old library, look for alternatives. If that isn't an option, you can use the command line flag add exports to export specific packages. But you know, if you're actually delivering software to your customer, then you have to tell him to update all his scripts. So there's a bit of shaming involved here on purpose to get you not to do that. And if everything else breaks and you think this is totally unfair, why me? You can turn to the Jigsaw mailing list. Then there are split packages, which is an interesting problem. The idea is that packages should have a unique origin. There should be just one module for each package. And the official wording is, no module must read the same package from 2 modules. So my module cannot read com Google Guava from that and com Google Guava from that other module. That sounds reasonable, but the implementation is extremely more strict. It says, no 2 modules can contain the same package, exported or not. If they do, it just breaks at launch time. So if you wonder why would anybody do that, well, I did the same. I didn't come up with too many examples, but there are some. For example, the Java XML packages are split with the XML RPs jar, which is something with Xerxes, horrible things I have heard about that. So some JBoss modules split Java transaction, Java XML. And if you're using the nullable annotations in JSR 3 or 5, well, that's a problem because it splits the JavaX annotation package. What can you do? You can look you can look through your code dependencies, whether it declares everything that's supposed to live in Java or JavaX. There's no automatic tool support yet. There may be soon. And this is the interesting part. A package that is split between the class path and a module, the class path package will be totally invisible, even to other people on the class path. So this will not break immediately, but might turn to very strange behavior. At least at the moment. Maybe they change these details, but yep, you should check for that. If you find something, what do? Is this split on purpose, really? Did you solve some problem with that? And if you did, you have to find another way. What you can always do, you can patch, not always, you can patch with a command line and add individual classes to modules. So you can tell the command line, this class, please put it into Java XML, in the Java XML module. And then there will be upgradable modules which replace runtime. Oh yeah, okay, sorry, yeah, runtime modules. I mean the JDK runtime modules, they can be replaced by modules that you provide. So you can, for example, replace the whole XML APIs, the Java XML module. Okay, we'll speed up a little bit just so you saw it. JDK and JRE, the folders will not look the way they look now. If you have classes that build paths and look into those folders, this might break. Don't do it. Then they have these mechanisms became obsolete. The endorse standards override and extension mechanisms, the boot class override, they're largely replaced by this upgradable module concept. If you use this, find an alternative. And yes, there's more. Check JEP 261 and look for more risks that come from Project Jigsaw. Interestingly enough, this is not related to Jigsaw, but might also break your code. If you ever looked into the version that Java returns and said like, oh, just take the one dot away and then we know the version. Yep, this is how strings look now, just to have it in mind. Nothing related to Jigsaw, but still it might break your code. Okay, so my general advice is these are the two things that you should worry about the most, I'd say. Generally, you should get your code in shape, you should check this and make sure that you're not violating any of these things, and you should also prevent relapses, if possible, by build tools and something similar. You have to check your dependencies and tools, and if any of them are suspicious, and tools mostly are, like all IDEs do fishy stuff with tools jar, which is gone, and other things, these will potentially break on Java 9. So, for example, you can't just take the current IntelliJ build and just launch it in Java 9, it just doesn't work at all. So you make sure that those projects are still alive, because otherwise you don't get an update. And you have to get your own versions up to date, because if you depend on some old version of whatever, and you cannot change it for whatever reason, then it doesn't help you that, for example, Guava 20 will totally be Java 9 compatible, but you are fixed to 12 and you cannot update. So if you have these dependencies where you say we use an old version that we can not update, and this version turns out to be problematic, then you have to work on that. Not necessarily now, but you have to fix it before you go to Java 9. Okay, general questions. Just as a note, I'm currently starting to write a book about exactly this, which has the same title as this talk. And if you like what I said about, what I talked about, maybe you can subscribe. You cannot buy it yet. I'm just starting. And this is a fake cover. It's going to be so much cooler when it's done. Okay, questions?
So how does this all work with class loaders? Can you load, for example, the same module in different class loaders? Or are modules related to class loaders? In which way?
Those people who know OSGI know that OSGI implemented their similar features by using class loaders. OSGI has one class loader per bundle. And this is the main reason why Jigsaw, it's the main official reason why Jigsaw didn't adapt OSGI approach, because they said there are so many people out there doing stuff with class loaders. If we change this meaning, it will break. So instead, we put in a layer below class loaders. So you used to get, when you got a class loader from a class, you used to get a URL class loader. That's what also on one of the slides, that's not true anymore. Now you get a module class loader. And this class loader knows about modules, but modules are, so to say, below the class loader. So you can do with class loaders whatever you want. And yes, you can load the same module in different class loaders. And there's also a concept called layers, which containers can use to create totally new module graphs. So they can take a totally different module path, for example, and load it into its own layer, which means it's its own class loader. In there, you have the fully connected module graph, and it can be independent, or it can delegate to the one below.
So you actually can do versioning with modules, but you have to do it in your application.
Exactly,
code.
you can, exactly. And this is one of the, this is a proposal I once sent to the mailing list, but I didn't follow up on it. It would be great if you could do that on the command line, right? If you could say, please do this Guava in one layer and this other Guava in the other layer, and then do the rest automatically. Maybe that will come to fruition, but yes, so you can do the same tricks as today with class loaders to get two versions running. That still works.
Will the JRE classes itself be split into different modules?
Sorry, will
the core Java classes?
Oh yeah, yes. There's a nice slide, I didn't put it on. It's like many, 50 or something. It's like a big graph, not everything is connected to everything. It's properly modularized, but it looks a little bit like that. And yes, and when you have a program, then you have to find out, like this import Java XML, for example, which module does it come from? Maybe Maven does that for you, but anyway, now you have to specify which JDK modules you depend on.
Thank you.
Can you hear me?
No, yeah, I can see you. Oh yeah, there.
Will the new modularized jars be compatible with older Java, like Java 8, if we compile them with older versions of bytecode?
As far as I know, yes. So the module info will simply be ignored, and you should be able to, if you compile them backwards compatibly, because I think there will be a bytecode change, and I think the new Java 9 code will have a new version, will be like 53 or whatever is the next bytecode version. But yes, if you compile to Java 8, it should be possible to use it on Java 8. Okay, if there are no more questions, I think we're done. Thank you very much.